Hi guys, today's lesson is lesson 100. Can you believe we're already on 100? That is crazy. We are going to be solving quadratic equations by graphing. We've already learned this, so this is just a review lesson. All right, if you will remember, the standard form of a quadratic is right here. 0 equals ax squared plus bx plus c. Remember that in order for something to be quadratic, it has to have an x squared. If it's not an x squared, it is not a quadratic function. All right, the graph of these always looks like a parabola. That is the U shape. It either opens up like that or down like that. And the solutions are also called roots or x-intercepts or zeros. So this is from page 669 in your book. There are three types of solutions for quadratic equations. So this top one here is when we have one solution. It's our one intercept. Oops. So here is, there we go. There is my solution. That would be at the point 2, 0. All right, in my second graph, I have two solutions. It crosses the x-axis twice. One right here and one right here. So those coordinates are 2, 0 and also 6, 0. And then this bottom one here is no real solutions because it doesn't cross the x-axis at all. The x-axis is way up here, and my parabola never touches the x-axis. All right, you already wrote this down from a few lessons ago, but just a reminder of the steps needed to graph quadratics. Step 1 is to find the axis of symmetry. We do that by using this formula here, x equals negative b over 2a. Step 2 is to find the vertex. Remember, that is the highest or the lowest point on your parabola. So we use the x coordinate we found in step 1, plug it into our equation, and then get our y coordinate. Step 3 is to find the y-intercept. That's x equals 0. Plug in 0 for x and solve the equation. And then we're going to find two more points on the parabola, and then we're going to graph it. So let's take a look at our first graph here. Our first equation is x squared minus 25 equals 0. So if you'll remember, we have an a value, a b value, and a c value. A is whatever is touching the x squared, and in that case it's 1. B is whatever is touching the x, so it's 0 because there is no plain x value here. And c is whatever's left, so that would be negative 25. So to find our axis of symmetry, we say x equals negative b over 2a. Negative b would be negative 0 over 2 times 1. Negative 0 is just 0, right? And 0 divided by 2 is 0. So x equals 0 for our axis of symmetry. All right, that's important. The next thing we want to find is our vertex. So if x equals 0, we're going to plug that in to our equation. So we have 0 squared minus 25, right? 0 squared is 0. 0 minus 25 is negative 25. So our vertex is at 0, negative 25. All right. Step 3 is to find our y-intercept. We're going to plug in x equals 0. Well, hey, look, we already did that. So our vertex happens to be our y-intercept in this case. Okay, so let me sketch my graph over here. All right, so we'll go negative 5, negative 10, 15, 20, 25. So I'm going to make it green so you can see it. So here is my vertex. That's also my axis of symmetry. So I'm going to represent that with a dashed line here. All right, so the next step is to find 2 points that are not on the line. So what would happen if x was equal to 1? Well, if I plugged 1 into my original equation, I would have 1 squared minus 25 equals 0. So 1 squared is 1, and 1 minus 25 is negative 24. So could I graph a point at 1, negative 24? Sure, that would be like right there, right? All right, let's plug in another one. What if x was 2? If x is 2, 2 squared minus 25 is 4 minus 25, which is negative 21. So that would be right around here, right? It's a pretty wide parabola. All right, the cool thing about the axis of symmetry is that it matches, right? So the distance from here to here is 1, right? So I need to go 1 on the other side and match that. So if x was negative 1, y would be negative 24, right? Right about there. And if x was negative 2, y would be negative 21. All right, we need to figure out where it's going to cross the x-axis. So you can probably guess that it is going to be 2 solutions right now, right? 2 solutions. So if we approximate our curve here, it's going to look something like that. All right. So it goes through approximately at 1, 2, 3, 4, 4.5. All right. So what if we, because it's, if you were thinking about factoring our original equation, you probably already know the answer is 5, right? So my graph is a little off, okay? It should actually go through right at 5 and negative 5, okay? So graphing, not the most accurate way to go unless you plug in all of the points, right? If you think about how to factor this, how do I get x squared? Well, that would be x times x. And how do I get 25? That would be 5 and 5. 1 is positive and 1 is negative. So looking at that, I know my solutions are going to be 5 and negative 5. I could set each of those parentheses equal to 0 plus 5 and then solve for x. So here x is negative 5 and here x is positive 5. All right. All right, let's try another one. 0 equals negative x squared minus 3. So step 1 is to find my axis of symmetry. Before I do that though, a equals negative 1. There is no b value again, and c is negative 3. So my axis of symmetry, x equals negative b over 2a. Negative b is 0 over 2 times negative 1 is 0 over 2, which is 0. So my axis of symmetry is at x equals 0. My vertex, I'm going to plug 0 in for x, so I get negative 0. Oops. All right, I get negative 0 squared minus 3. 0 squared is 0. 0 minus 3 is negative 3. So my vertex is at 0, negative 3. Okay, if you remember, because this is a negative x squared, my parabola is going to open down, right? It's going to open down. So this is going to be my highest point here because my parabola is going to open down. All right, my y-intercept we already found. It's the same as my vertex, 0, negative 3. So let's graph this. Let's see, 1, 2, 3. Here's my vertex. All right, now I should do it in green like I did last time. All right, so now we have to find points that are not the axis of symmetry. So let's plug in negative 1. So if x equals negative 1, I have negative negative 1 squared, right? Negative negative 1 is really just positive 1 minus 3. So 1 minus 3 is negative 2. So I can graph negative 1. All right, actually, I totally just made a mistake right there. So let me write it in red so you can see what I did wrong. So if we look back up here, we have negative x squared. But notice it's not in parentheses like this, which is what I did down here, which made my answer wrong. The reason I knew it was wrong was because when I graph negative 1, negative 2, if I made this parabola like this, that would not be a negative x value because my parabola should open down, but when I graphed it that way, it actually opened up, which is not what we wanted to have happen. So let's get rid of that. Okay, let me erase this and try it again. So I actually want to do negative 1 squared minus 3. So here, negative 1 squared is positive 1. But then I have this negative sign out front still. So it's negative 1 minus 3, which is negative 4. So if x is negative 1, y is negative 4. So let's graph that. 1, 2, 3, 4 right here. Okay, remember this is the axis of symmetry. So I know that this point is going to match up on the other side as well. So my parabola is going to look something like this. And you know from where this graph is that my answer, like what's the solution here, would be no solution because my graph never actually crosses the x-axis. All right, let's look at one more. Here we have x squared minus 3x minus 18 equals 0. So a is 1, b is negative 3, and c is negative 18. So I'm going to start with my axis of symmetry. X equals negative b over 2a. Negative b, so b is negative 3. The opposite of negative 3 is positive 3 over 2 times 1. So it's 3 over 2, right, which is 1.5, which is not a very convenient thing to graph when you're not on a computer program. All right, so to find my vertex, I'm going to plug 3 over 2 in for x. So I have x squared minus 3 times x minus 18. So 3 over 2 squared is 9 over 4 minus 3 over 1 times 3 over 2 is 9 over 2 minus 18. All right, so now I got to get some common denominators here. 9 over 4 minus 18 over 4 minus, what is 18 times 4? 32, 72. All right, ooh, this is fun. Let's see, 9 minus 18 is negative 9, and negative 9 minus 72 is 72 plus 9, 81. 9 plus 2 is 11. Whew, all right, negative 81 over 4. Well, that sounds super fun to graph. What is 81 divided by 4? 4 goes into 8 twice. Minus 8 is 0. 20 and 1/4. What a great vertex. 3 over 2. Actually, I'm going to write it as a fraction just so I can graph it easier. Not a fraction, a decimal. 1.5 and 20 and 1/4. All right, let's see. We know this one's going to open up, right? Because it's a positive x squared. So why don't we graph that? Oh, we need to find our y-intercept. Sorry. All right, y-intercept when x equals 0. So 0 squared minus 3 times 0 minus 18 equals 0. These go away. So negative 18 is my y-intercept. 0, negative 18. Okay, let's graph that fun thing. Let's see. We'll go 2, 4, 6, 8, 10, 12, 14, 16, 18. So here is my intercept. And my vertex is positive 1.5 and negative, I didn't put the negative sign on here, negative 20 and 1/4. So positive 1.5, negative 20, just past negative 20. So right about there. Okay. Black pen. All right. So that is my vertex right here. So that's where if I folded it, it would be the same on both sides, which means that if I go 1.5 spots in the other direction, I should match, right? Here's my half, here's 1, so it should go right here. All right, so here's the start of my vertex. Okay, So let's plug in, no, I don't know, how about -3? Because that seems far enough away. So if I plugged in -3 for x, I would get -3 squared minus 3 times -3 minus 18. -3 squared is 9. -3 times -3 is +9 minus 18. 9 plus 9 is 18. 18 minus 18 is 0. Oh, look, I stumbled upon my solution here. So when x is -3, y is 0. 1, 2, 3. All right, so let's see if we can match that on the other side. So how far away from my axis of symmetry is this? It is 1, 2, 3, 4.5. Here's my half. 1, 2, 3, 4. I can't even see it over here. So, sorry guys. Let's see. So if I graph this right, I would be at 1, 2, 3, 4, and I need to go 2 more, but I ran out of room. So it would actually cross at 6, 0 as well. So my two solutions for this one are -3, 0, and 6, 0. So hopefully this showed you that graphing quadratics is not the easiest way to find the solutions here. All right, if your book tells you to use a graphing calculator, please use Desmos.com if you don't have a graphing calculator. It will do the graph for you real fast. And if you would like some more practice problems, check out page 673 in your textbook. Let me know if you have any questions. Thanks, guys.